Welcome everyone. This is your math tutor Naresh. This is the second video of Introduction to Exponents tutorial. So let's continue where we left off in the previous video. Now some things you should know. So let's start with a base of 1. So 1 raised to the exponent 0. We know that's 1 by definition. Anything raised to the exponent 0 is 1. If we have 1 to the 1, that's 1, 1 to the 2 is 1, 1 to the 3 is 1, 1 to the 4 is also 1. So anything raised to the exponent 1 is going to be 1, so I'm not going to bother continue with this. So that's trivial. So these are the things you should know, like you should know them by heart. So for example, if we start with the 2, right, after 1 comes a base of 2. So base 2 raised to the exponent 0, that's 1. 2 to the 1 is 2. Now what's 2 to the 2? 2 to the 2 is, we're multiplying 2 twice. So you go 2 times 2. So 2 times 2 is 4. So that's 4, right? And what about 2 to the 3? 2 to the 3 means you're multiplying 2 3 times, once, twice, 3 times. So 2 times 2 is 4, times 2 is 8. And then what about 2 to the 4? 2 to the 4, it simply means you add another 2 here, right? So this was 8. 8 times 2 is 16. Or you can look at this answer, 8 times another 2 is 16. So what about 2 to the 5? 2 to the 5, the answer is 32. So we already know 2 to the 4 is 16. We're multiplying that by another factor of 2. So 16 times 2 is 32. And then 2 to the 6, so it's 32 times 2 is 64. Then 2 to the 7, 64 times 2 is 128. So you should know this up to 2 to the 7th, I would say. You should know that by heart, or you should be able to calculate it in your head pretty quickly. Okay. So now let's do something similar with the base of 3. So 3 to the 0 is 1. 3 to the 1 is simply, we're multiplying 3 only once, so it's 3. 3 squared, so we're multiplying 3 twice, so 3 times 3 is 9, so we get 9. What about 3 to the 3? So we're multiplying by another 9. So we already know this is 9. 9 times 3 is 27, right? Or you can look here, your 3 squared was 9, so 3 cubed, so it would be 9 times another 3, 27. And what about 3 to the 4? So 27 times 3, so you can multiply in your head by hand or in calculator, right? So 27 times 3 is 81. So that's 3 to the 4. So I would say that this is good enough. So up to 3 to the 4, I'll throw in just one more, 3 to the 5, so 81 times 3. So 3 times 1 is 3, and 3 times 8 is 24, right? So for base 3, you should know up to maybe 3 to the 4 or be able to calculate it pretty quickly. So I don't have these memorized, but they sort of got memorized. I actually do know them by heart. Okay, so now let's go to the base of 4. So again, we're not doing anything different. I'm just going in the order of exponent 0, 1, 2, 3, 4, and so on. So as the base gets big, you know, the numbers, the answers also get bigger. So 4 to the 0 is 1. 4 to the 1 is 4. 4 squared. So 4 squared, that's 4 times 4, and that is 16. Okay, so next 4 to the 3, so that's 16 times another 4, so that's 64, right? So times another 4 here, so 4 times 4 times 4, 16 times 4 is 64. And then 4 to the 4, so that's 64 times 4. So 4 times 4 is 16. 1 carry over. 4 times 6 is 24. Plus 1, 25. So that's how much you should know, up to 4 to the 4. And now we can continue, okay, with base 5. So these are the bases that are most commonly used in algebra. So that's why if you know them by heart, or if you can calculate them pretty quickly, then you'll save time. So base 5, 5 to the 0 is 1, 5 to the 1 is 5, 5 to the 2, so that's 5 times 5 is 25, 5 to the 3, so 25 times another 5, so that's 125, and then 5 to the 4, 5 to the 4 would be 625. So 125 times another 5 is 625. Alright, so these are, so I would say up to base 5, so this is how many you should know. Okay. So now let's look at squares. So I'm going to square the bases, and these are the squares that you should know by heart. So if we have 0, square that, you get 0, right? 0 times 0 is 0. So what about 1 squared? 1 squared is 1. 1 raised to the any exponent is always 1. Now 2 squared. 2 squared is 4, right? 2 times 2 is 4. 3 squared. 3 squared is 9. 3 times 3 is 9. 4 squared. 4 times 4 is 16. 5 squared. 5 squared, 5 times 5 is 25. 6 squared, that's 36. 6 times 6 is 36. And what about 7 squared? 7 times 7 is 49. 8 squared. 8 times 8 is 64. 9 squared. 9 times 9 is 81. 10 squared. 10 times 10 is 100. 11 squared. 11 times 11 is 121. 12 squared. 12 times 12 is 144. So that's how much I would say you should know by heart. So for the squares, up to 12. Okay. Now let's look at cubes. We work with squares a lot, we work with cubes a lot, so that is the reason why you should know these by heart. Okay, so again, 0 cubed, that would be 0. 0 times multiply 0 by itself 3 times, you'll get 0. And then 1 cubed would be 1. 1 multiplied however number of times will still produce 1. Now 2 cubed. So 2 cubed is 8. 2 times 2 times 2. 2 times 2 is 4. Times another 2 is 8. 3 cubed. So 3 to the 3. So 3 times 3 is 9. Times another 3 is 27. So 3 cubed is 27. And what about 4 cubed? So 4 cubed means 4 times 4 times 4. 4 times 4 is 16, times another 4 is 64. And what about 5 cubed? So 5 cubed, 5 times 5 is 25, times another 5 is 125. 6 cubed. So 6 times 6 times 6. So 6 times 6 is 36. 36 times another 6. So 6 times 6 is 36, 3 carry over, 6 times 3 is 18, 18 plus 3, 21. So 216. So for a basis, for cubes, you should know up to basics. Okay, so this is, so squares and cubes, so these are the ones you should be fairly comfortable with. Okay, so now let's look at an example with a negative in the base. In the previous tutorial, we looked at 1 raised to certain exponents, right, and then also negative 1. So this time, instead of working with the negative 1, I'm going to work with the base of negative 2. So we have a base of negative 2. Actually, let's do the same thing. No, that's fine. Let's continue. So negative 2 raised to the exponent 1. Okay. So this is equal to negative 2, right? And now we're going to compare this. What if we wrote negative 2 as is raised to the exponent 1, where the base is not inside the brackets? So here the answer is the negative gets copied, 2 to the 1 is 2. So in both cases the answer is the same. Now let's look at negative 2 raised to the exponent 2. So in here, right, when we expand this, we multiply the base of negative 2 twice. The answer that we get is negative times negative is positive. 2 times 2 is 4. So what I'm trying to teach here is how this base plays out with the negative. Now, in comparison, let's look at this question, negative 2 raised to the exponent 2. So in this case, the exponent of 2 applies to the base that immediately precedes it, which is 2. But this exponent does not apply to the negative sign, right? So the negative sign is on its own. So here, when we simplify, we copy the negative, and then we're saying this 2 will get multiplied 2 times. So multiply twice this base, right? So here the negative stays, 2 times 2 is 4. So that's the distinction you need to make and understand for yourself. So here the negative is inside the bracket, it is also being squared. So when you have a negative 1 raised to an even exponent, the answer is positive. And here you have negative to which no exponent is being applied, right? It's just negative factor of negative 1 in front of the 2. So that's the distinction you need to make in your mind and you need to understand. Now let's continue. So I'm going to erase. We're still going to work with the base of negative 2. So we'll do maybe 2 more examples so that you grasp the concept. And you can always pause the video, do it by yourself, and then replay the video. So now let's look at negative 2 raised to the exponent 3. So here we're saying the base is negative 2 because it's inside the brackets. Multiply 3 times. So from our multiplication addition rules, negative times negative is positive, times negative is negative. 2 times 2 is 4, times 2 is 8. So the answer is negative 8. In other words, we said we have a negative factor of negative 1 multiplied with 2 raised to an odd exponent. It's going to be negative. Now in comparison, so negative 2 raised to the exponent 3. And again, I'm going to repeat myself. The exponent of 3 only applies to the base that immediately precedes it, which is the base of 2. The negative here is a negative 1 factor multiplied with 2 to the 3. So the exponent of 3 does not apply to this negative 1 factor. So that gets copied negative. And now we write this base 2 3 times. And this is why I like to use brackets, because when I use brackets, I am giving clear instructions to myself and to my readers and whoever is going to look at this work. So negative stays on the outside as a factor of negative 1, and I'm multiplying 2 and 2 and 2, so 3 times. So here I'm getting also negative 8. So negative 8 here, negative 8 there. So make the distinction why it is the same answer in this case, where it was different by the sign in the previous example that we looked when we had even exponent. Alright, so now we'll do one more example with an even exponent. So negative 2 raised to the exponent 4. So this means negative 2 is the base. We multiply that 4 times. So again, so negative raised to an even exponent, the answer is going to be positive. And we knew that, we know that, right? So negative times negative is positive. This negative times that negative is also positive. So positive times positive is positive, right? That's another way of looking at it. So the answer is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now compare negative 2 raised to the exponent 4. So here, so the exponent of 4 does not apply to this factor of negative 1, which is in front of the 2. So negative gets copied, 2 gets multiplied 4 times, 2, 3, 4. So this negative gets copied. So 2 times 2 is 4, times 2 is 8, times 2 is 16, so negative 16. So make that distinction. Why is this positive 16? Why is this negative 16? And the answer is we have even exponent, right? So that's the answer. So negative raised to an even exponent is positive, and here the even exponent actually does not apply to this negative, right? Because it's on its own on the outside. So make that distinction and understanding for yourself. All right. So now let's look at some examples. So now maybe we can go backwards. So rather than being given the base with an exponent, so how about if we give you an answer and we ask you to come up with the base and the exponent? So here we go. So we're given 25. So write with exponents. So write with exponents. So that's a question. So how do we write 25 in terms of an exponent? So it simply means if you have an exponent, then you're also going to have a base. So 25, we just did our squares, right? So what number multiplied by itself, however many number of times, will give us 25? Well, the obvious answer here is, if you couldn't think of anything, you would just say 25 raised to the exponent 1, right? Like, you'd be done, right? So, but in this case, what we're looking for is, right, in this case, if you write 25 to the 1, you're really not doing any thinking, right? So in this case, what I would want to see is a base of 5, and 5 multiplied how many times gives us 25? So 5 multiplied twice by itself will give us 25. So 5 to the 2 is 25. So this is the answer that I'm looking for here. Now another example, 8. So how do we write 8? So again, 8 raised to the exponent 1, that's always the answer, right? And that's the obvious answer, so we don't want that one. So let's try with a base of 2. So if I start with a base of 2, multiplied it a few number of times, will I get 8 at some point? 2 times 2 is 4, times 2 is 8. Okay, I get 8 if I multiply 3 times. So 2 raised to the exponent 3 gives me 8. So that's how it's trial and error. You're thinking backwards, right? So, but it can be done. So what about a 4? So 4, again, start with the base of 2, because that's the lowest base we can start with, right? 1 is kind of irrelevant in this case. So 2 times 2 is 4. Okay, so 2 times 2 is 4, so that's 2 to the 2. Now what about 125? 125, so 125 it's a factor of 5, so we don't want to start with 2 in this case. 2 never will give us 125, right? So 5 makes more sense. So start your trial and error process with a 5. So 5 times 5 is 25. 25 times another 5 is 125. So it's 5 to the 3. Alright, so now let's look at 64. 64. So here you can have more than one answer. So if you start with the 2, so you know that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay, so 2 to the 1, 2, 3, 4, 5, 6. So 2 to the 6 gives me that. Now, or you could have started with a 4, let's say, base 4. So 4 times 4 is 16. 16 times 4 is 64. So that would be 4 to the 3, right? Or we could have started with base 8. So what's 8 times 8? 8 times 8 is 64. So that would be 8 to the 2. So here, I'm looking for any one of these answers, right? It's just that we want you to be able to go back and forth. So you're given a number, can you put it into the base and exponent form, and vice versa, right? Okay, so now let's do maybe a couple of examples where we will write in the exponent notation. So if you're given something like this, so 3 multiplied, let's say 4 times. So how do you write this in exponent form? So the base is 3, because that is what is being multiplied. And how many times? 4 times. So the answer here is 4. Now, another example. So let's say 10x times 10x times 10x. So how do you write this in the base and exponent form? So the base is 10x, that is what is being multiplied. How many times? Once, twice, 3 times. So there, that's the answer. So I'm going to wrap up this example here, but we will do more examples in the third video, and that will be the final video for Introduction to Exponents. So if you found this video useful, please click like or subscribe, and thank you for watching. We will see each other in the next tutorial. Once again,